Today's topic is memory management. What is memory? Memory is nothing but RAM, your physical memory, how your SAP application is utilizing memory. That is what memory management, how effectively it is utilizing memory. So it is a sensitive topic. See, for example, I am having some 16 GB RAM. So I have done some central installation. You know what is central installation? Application as well as database both are installed in your same machine. That is called as a central installation or standard installation. So first I installed operating system. Okay, after that I installed some database like Oracle database. Then I installed SAP. So when I'm installing Oracle database, I have assigned 6 GB of memory for my database. For operating system, it has taken 4 GB to start up all those processes, everything. For Oracle database, I gave Oracle instance, I gave 6 GB memory. For SAP, out of 16, 10 gone. So remaining 6 GB I gave for SAP. So what is instance exactly? To start any application, it requires some RAM memory plus some background processes. Yes or no? The collectively that collectively called as a instance. Means processor has to start some processes and your physical memory has to allocate some memory to each and every process. The operating system is a big application. On the top of that you are installing database, that is also big application, and SAP, this is also big application. So it is not small application to start one process. When you start your operating system, by default it will start nearly 100 processes in backend if you go with the task manager. The same way when you start Oracle also, some hundreds of 50 to 60 processes will start, and each and every process requires memory. If you remember your architecture class, that is what collectively we call as instance. Instance is collection of memory plus some processes. Who will give these processes? Your processor. Who will give this memory? Your RAM. The combination of these two to start any application is called as an instance. So how many instances I am having here? 3 instances. One is operating system instance, second one is Oracle instance, third one is SAP instance. Okay, I'm having 3 instances here. See, so operating system also has some memory structure, how your operating system occupies memory, and this operating system also having some processes. We are not going to discuss about that operating system, so we are not OS admins. Fine. So if you know some Oracle database, when you start Oracle database, there is something called SGA, System Global Area. How it allocates memory means it will have some, for example, this 6 GB is distributed into buffer cache, Redulog buffer, shared pool, stream pool, Java pool, large pool, and fixed SGA. These are memory areas of your Oracle database. When you start Oracle database, it will total SGA memory is 6 GB, means entire Oracle memory is 6 GB. It will allocate this 6 GB, it will occupy this 6 GB of memory, plus it will start some background process like DB writer, log writer, checkpoint, SMAN, and PMO. The same way, whatever the database, it will have some memory structure, it will have some processes. The combination of this memory structure plus processes is called as instance. If it is a database, database instance. If it is an operating system instance. The same way, how every application has some memory utilization mechanism, the same way SAP also having some memory utilization mechanism. That is what we are going to discuss today. And you know, when you start your SAP application, it needs some memory. When you are installing your SAP, you are giving some physical underscore mem underscore size instance memory you are giving, right? That memory is 6 GB according to this example, not entire. And when you start your SAP system, it will occupy that 6 GB memory. Under that 6 GB, it will have some different memory areas. Today we are going to discuss that. Plus it will start some processes like dialog, background, update, spool, enqueue, message server, gateway. All these these are processes. If you open it your task manager, you can see each and every process there. Displace work.exe, msg server.exe, start SAP, stop SAP, jwrd.exe, all these processes. The combination of this is called as SAP's instance. Is it clear? So today we are only going to discuss about this memory area, which is this 6 GB SAP memory. We are not discussing this one. We are not discussing operating system memory. We are only today here discussing SAP's memory structure. So when it comes to this memory structure, we are having different memory areas. One is role memory, second one is extended memory or shared memory, third one is called as heap memory or private memory. You will get this regular interview question. If a work process goes into private mode, what will you do? You don't know, right? Today you are going to learn that private memory, what exactly that private memory is. So when we are discussing about background job administration, how this background work process different from dialogue work process? In two ways. I told you on that day. In 2 days. One is dialogue work process has a runtime limit. Rdisp. This is a parameter which is restriction in dialogue work process. Rdisp slash max underscore wp run underscore time, which is 600 seconds. Right. That is one thing. The second reason is the memory usage sequence of dialogue work process and the non-dialogue work process are different. What I told you on that day, please have this sentence with you. At the time of memory management concept, we will discuss how this non-dialogue work process utilizes memory. Did anyone remember that?
Yes,
Means
sir.
the memory usage sequence of dialogue work process and the memory usage sequence of non-dialogue work. Non-dialogue work process means all your other work process, background updates, pull everything are different. How different we'll see today. Okay. Before going to this, first of all, you should understand few things. Wait for a minute. User context. There is some technical words. What is that? User context. User context means when you log in into the system, from login time to logout time, whatever the things you have done, everything will be comes under user context. See, I logged into the system and I have performed so many operations. I hit SCC4, SCC5, ST01, ST06, anything, and I log out. All this when I logged in, when I logged out, whatever the things I have done, everything comes under my user context. Yeah, user login time to user logout time. So this user context, you can, if you want to give some explanation to this user context, so you can say initial information plus external session plus, you can say, plus internal session. External session plus internal session. User context means initial information. What is initial information? Every user will have some basic information, right? Username, user authorizations, password, address, everything. So when you log in into the system, all these information plus external session means whatever the transactions you do by hitting some T codes, by running some programs, whatever you do by your own, that are called as external sessions. So I hit ST04, ST03, and I ran some program, RSTP test. All these comes under external sessions. And what is the internal session means? When I call some SCC4 T code, what happens? Just I am hitting the T code, you are getting the screen. How you are getting the screen? When I hit any T code, the system itself calling some program. Yes or no? And it is connecting to the database and it is passing some SQL statements, call screen, call module, call table, and that interpreters everything, and it is giving you the screen. Whatever happens internally are called as internal sessions. So when you execute some statement, that is comes under external session. User executed commands, and system internally calls some programs, some reports, some screens, right? When you hit some T code, you are getting some screen. How you are getting? System is internally calling something. So when you hit SEC4, some associated program is calling internally, and some SQL statement is passing to the database. From the database, it is fetching that information and presenting you. All this comes under internal session. User context means initial information of the user plus whatever the external commands he hit, that things, plus whatever system internally calls that thing. This entire thing is called as user context. Is it fine? Any doubts here? Initial information of the user plus external sessions and internal sessions from login time to logout time. When you log in, first of all you will be having initial information will be added, then you will hit some T codes, that is external session. When you hit T codes, the system internally calls some screens, that is called as the internal sessions. The combination of these three is called as your user context. Every user will have his own user context. Is it fine? Any doubt here?
No, sir.
Yes.
No, no doubt. Okay. Now we will when comes to dialogue work process and non-dialogue work process, these two work processes you utilize memory differently. How they are utilizing memory, we'll see now. See, I am having three types of memory areas. One is role memory, second one is extended memory, third one is heap memory. First memory is role memory, second memory is extended memory or shared memory, third memory is heap memory, or you can say private memory. You can say private memory. So what happens? Every work process has some local role memory here. Okay, for example, I am having some 5 work processes. Each and every work process has some memory area. Local memory means this memory is specific to that work process. Where this memory is allocated means there is one parameter called ZTT underscore role underscore first. In role memory, you are having two things, role first and role area. In role first, each and every work process has some initial memory. That memory is 1 byte. How much memory? 1 byte. Can you fit your name in your 1 byte of memory? 1 byte, not a 1 KB, 1 byte. No, it is not possible to fit even your name there. Fine. So when you log in into the system, one of the work process with 1 byte of memory will give you login. So when you log in into the system, initially you will be having some user context. What is initial user context? Your initial information, your user ID, password, authorizations, everything. So to store all these things, that 1 byte of memory is sufficient? No. This this work process has 1 byte of memory. Is your user context initially is more than 1 byte? Your name itself more than 1 byte. Then how come it store all these information? So what it will do? It will copy this user context from role memory to extended memory. At the time of logging in only, it is copying user context from role memory to extended memory. This activity is called as roll out. What we used to call it as roll out. You'll get just 3 to 4 questions here from memory management. What is rollout? From role memory, it is coming out. That is the reason we used to call it as rollout. Copying user context from role memory to extended memory is called as rollout. Fine. Now here you will be having some memory, em underscore initial underscore size underscore mb. This entire extended shared memory size, this parameter will decide. For example, let's take 2 GB, 2 GB of memory. And ZTT underscore role underscore extension underscore dia means for each and every work process, I cannot give entire memory to only one work process. There are so many users are logged in. Like this, so many rollouts is happening. So many users are logging into the system. So I cannot give entire memory to that only user. So it is a restriction. It is a total memory. It is a restriction for a dialogue work process. For let's take, for example, it is 10 MB. Okay, I'm not sure. 10 MB I'm giving. So if this memory, for example, your work is going on, you're doing some process, you are processing some program, you are executing some program, within this 10 MB it has to be finished. Otherwise, after reaching 10 MB, here the limit is exceeded, right? So what it will do, okay, wait here. So let's take, I am going from LB Nagar to Kukatpalli, or else I'm going from Hyderabad to Mumbai. I'm going from Hyderabad to Mumbai. This work process is taking me from Hyderabad to Mumbai. So in between Sholapur I stopped for having cup of coffee. At that time you are waiting, you are chit chatting with your friend, and that work process will not be stay with you. Why unnecessarily idle work process? So what it will do, it will go here and stay, it will ready to serve some other user. Instead of waiting with you, it will go there and ready to serve with you. After having your coffee and you want to start your journey again, at that time, whatever the free this work process has taken you to here, but now this work process got busy in some other work. So whatever the work process is in waiting condition, that work process has to take you from Sholapur to Mumbai. So how come this work process knows your information? So what happens then, this user context will be copied from extended memory to role memory, not entire user context. User context is so much of information now. Initial information is there and you are hitting some T code, that information also added now. So this memory is what? Only 1 byte of memory I am having here. So I cannot store entire user context. So what it will do? Only it will throw the pointer information, means exact location of yours. So it will go user copying user context from extended memory to role memory. That is called as roll in. What is that called as? Roll in. Copying user context from extended memory to role memory is called as roll in. What is roll out? Copying user context from role memory to extended memory is called as roll out. Copying user context from extended memory to role memory, it is coming in. So I am calling it as roll in. Clear up to here? Okay. This, please respond.
Yes, sir.
Yeah, thank you. So
Yes,
here,
sir.
what is the limitation I am having here? This work process has limit here, 10 MB only. By using 10 MB of memory, you have to complete your transaction. If not, I have 2 GB of memory. Total memory is 2 GB, but my limitation is 10 MB only here. So after using this extended memory, it will use ZTT underscore role area memory. It will use role area memory to execute your program. Okay. Here also total memory of this area is ZTT underscore role underscore area. Here also you will be having one parameter which is restricting your limit to somewhat some 5 MB or 6 MB, 7 MB. After reaching this role area is called 1 GB, but it won't allow you to utilize entire 1 GB area for only one dial process. So after reaching the limit here, it will go to heap memory. That is what we call it as work process going into private memory. So first what it is using? Roll first, right? From roll first to extended memory. From there, role area. From role area to, it is using heap memory.
Heap memory.
This is how your dial work process will utilize the memory. So when the work process comes into heap memory or private memory, why I am calling it as private memory, why I am calling it as shared memory means, remember here the user context is sharing between different one work process has taken you to here and other work process taking you. So this user context is sharing between the work processes. That is the reason I am calling this extended memory as shared memory. But the work process which taken you to private memory, that work process has to finish the work. It cannot share this user context to some other work process. That is the reason I am calling it as private memory. When the work process comes into private memory, that work process has to finish that work there. Here we get three conditions. The work has to, the final memory area is what? Your private memory. You don't have extra memory. So your work has to be completed, means your transaction has to be completed. Whatever the program you are executing, that has to be finished. Other, that is one condition. Second condition, it has to go into loop. Third condition, the program will be terminated. These three things will happen. First condition is what? It has to finish the work. Second condition, otherwise it will go into loop. Third condition, it will terminate your program. So when the work process comes into private mode, that is a danger sign. If a dialogue work process comes into a private mode, the work has to be completed. Otherwise, it will go into the loop. Otherwise, it will be terminated. Is it clear? So here also in heap memory, for example, total, there is one parameter called abap slash heap underscore area underscore total. Abap slash heap underscore area underscore total is 2 GB, for example. The parameter value is 2 GB. The total heap area is 2 GB. From that, for dialog instance, I am giving dialog purpose, I am giving 1 GB. For non-dialog purpose, I am giving 1 GB. So what happens after here? You can utilize 1 GB of memory. Dialog purpose has taken you to heap memory. So here you will get 1 memory of space. And within that space, within that memory area, you have to execute your program. Otherwise, it will be terminated. So what SAP is suggesting, so if the abap underscore heap underscore area underscore total is equal to 2 GB, so don't give any restrictions here. For dia give 2 GB, non-dia give 2 GB. What is happening here? So after reaching 1 GB, it won't terminate. It will get another 1 GB. If you give total is equal to 2 GB, dia is equal to 2 GB, non-dia is equal to 2 GB, what happens? There is more chances of finishing up the work. Yes or no? If I restrict here, it will only use 1 GB. If I don't restrict here, it can utilize up to 2 GB. Very rarely the work process will comes into private memory. When it comes accidentally, it has to finish your work. That is what our main motto, right? So if you give restrictions here, what happens? You have 1 GB left, the free space, but your transaction got terminated. That is the reason SAP is recommending to give this total is equal, dia is equal to 2 GB, non-dia is equal to 2 GB. Means if dialog process comes into private memory, it can utilize 2 GB of memory. If the non-dialog comes into memory, it can utilize 2 GB of memory, so that the chances are increasing to finish your work. This is how your dialog process will utilize the memory. So first role first, then share extended memory, then role area, then heap memory. Memory usage sequence of dialog work process this. Any examples correlate with this? Okay, I'll try. Okay. So you went to the party. Okay. This one is ZTTA role first is your starters. Okay, you ate starters, but still you are hungry. Okay. Then you ate, you come to main course. This is your main course, extended memory. See, if you observe the size here, I intentionally drew this thing. Which memory area is more here? Extended memory. That is the reason I am comparing this as a main course. Okay, you ate main course also, but still you are hungry. Then go to desserts. Okay, after eating desserts also, your belly is empty still. Then go to kitchen. Three things will happen if you go to kitchen. What happens? You have to fulfill your hunger by eating all the things at kitchen. Otherwise, after eating all these things, your stomach will get upset. Third thing, they will kick you out of the kitchen if you are eating that much. These three things will happen. Is it correlated? Yes or no? Please
Yes, sir.
respond. The same way, dialer
Yes,
process
sir.
first use this role first, then extended memory. If at anyhow it won't be used sufficient. That is sure. Why 1 byte of memory? What you do? What transaction you complete within 1 byte of memory? Even your name is not suitable there. So definitely, even though you are hitting a small T code, that will be finished here only. So it will use first role first, then shared extended memory. If it is not sufficient, then it will utilize the role area. If it is also not sufficient, then it will use to he- use heap memory or private memory. If the work process goes into private memory, what you do? Don't immediately kill that work process. So give some time. There are some parameters. So you can restrict the number of work process which are going into private mode. So if you give 4, the parameter value 4. So more than 4, if the fifth work process comes into private mode, the first one which will comes into private mode, that will be terminated. So only 4 it will allow you to come into private mode at a shot. And you can have some time limit also. After reaching 600 seconds into private memory, it will be terminated. Within that limit you have to finish the work. Like that you can do the tuning of your memory parameters. That is we'll discuss it at the time of interview preparation. It is too early to discuss all those things now. So role first, extended memory, role area, then heap memory. This is the memory usage sequence of your dialer work process. Now comes to non-dialer work process. This is for dialer work process. Dialer work process. If it is non-dialer work process, what it will do? So non-dialer work process first utilize shared memory, then private memory, then utilize role area. Who is this? Your non-dialer work process. Non-dialer work process will use first extended memory, then heap memory, then role first. So dialer work process mostly using which memory? Extended memory. Non-dialer work process mostly using which memory? Heap memory. So that all memory is sufficiently utilized, equally utilized by your work process. If all the work process are utilizing the same level, only extended memory will be utilized more. This memory area will be empty all the time. So SAP has make this memory usage sequence different for dialer work process and non-dialer work process. Non-dialer work process mostly utilize this area, which heap memory. Dialer work process mostly utilize extended memory. And if you want to have good performance of your system, you can generously give extended memory. Mostly used memory area is extended memory. So if you have sufficient memory, give this parameter em underscore initial underscore size underscore mb and ztta role underscore extension underscore dia non-dia generously. Then your memory tuning will be good. And remember this: if you are good at memory management, your entire system's performance depends upon what? Your resources. The major resources are what? Your memory and your processor. If you fine tune this memory parameters, your system's performance will be good. If you say I know only memory management, I am master in memory management, and you ask demand for 15 lakhs package, definitely they will give you. So prepare only one topic. You don't know anything in SAP, only you know memory management. If you are a master in memory management, that's enough. That is my suggestion for you guys. Do R&D on this memory management and how it is utilizing memory, what all these parameters. There are so many buffers, not only these memory parameters, you'll be having so many buffers in this. For entire thing, you will be having one T code called ST02, memory tuning. If you go to this ST02 T code, you will find all the buffers, all the memory parameters there. You have to fine tune that. Entire your system's performance majorly depends upon your memory utilization. If you configure this, if you fine tune these memory parameters, the performance will be good of your system. The main motto of any basis consultant is what? to make your system work without any difficulties, to run your system smoothly. That is what your main goal of any basis consultant, right? Why they are giving you salary? You have to maintain your systems properly. Hustle free utilization should be there, right? So if you are fine tuning your memory parameters, that is enough for your client. If you are master in memory, that's enough. You don't know even a user administration, client administration, no, nothing. You know only st02 screen and all this memory, how your SAP system is utilizing memory. That's enough. You can demand your package. That's how important is this topic. This is somewhat a tricky topic and a confusing topic. If you want to master, please go and get the master. Any doubts here? What is rollout? Anyone? Copying user context from role memory to extended memory is called as rollout. Copying user context from extended memory to role memory is called as roll in. What is user context? The initial information and the external sessions plus internal sessions. The combination of these three is called as user session. How your dialover process utilize memory? The memory usage sequence of dialover process: role first, extended memory, role area, heap memory. A non-dialover process memory usage sequence is extended memory, heap memory, and role area. Can I show you all these things? Yes, go to your ST02 T code. You will get all these things. And remember, this memory management concept is somewhat changed now. How it is changed? I'll tell you. Is there any use of this role first? 1 byte of memory? No, at anyhow, directly it is copying into user context, copying into your extended memory. And all these are now clubbed into extended memory only. In the new versions, you don't have this role memory concept at all. You don't have this role memory concept, role first parameters, ZTT, role area parameter. No, you'll be having only two things: extended memory and this heap memory. You have only two things. What are they? Extended memory and this one, heap memory, in new architecture. But one of my student in interview explained about this extended memory and heap memory only. So the interviewer said, where is role memory? So most of the people don't know this new architecture. That is the reason I am showing you this role memory, extended memory, and heap memory. But from new architectures, this role memory is obsolete now. I'll show you that if you have any doubt. Allocation sequence of dialover process: first extended memory, then directly heap memory, private memory for dialover process. The second one is heap memory first, then extended memory. Where is role memory? If you go with the parameters also, memory types in SAP memory, there is no role memory now. See, shared memory, extended memory, global, private memory, proc memory. So this is the new architecture actually. Nobody knows this.
Sir, sorry for the interruption. I couldn't
Yes,
see a screen.
my screen is not visible.
Yeah.
Okay, wait. For everyone or only one?
Yeah, now it's
It is visible.
Now it is visible, right? See, it is what a zero administration memory management. So in earlier days, we used to, when you are installing your SAP system, you have to configure this role memory, extended memory, and your private memory manually. All the parameter values we have to give manually. After that, SAP come up with a concept called zero administration memory management. By having this, just it will ask you physical underscore mem underscore size parameter. At the time of installation, it will ask you this. So your instance memory, it is nothing but your instance memory. While we are installing, we have seen Guys, did you remember? From 8 GB of memory, it is taking 4 GB. I have shown you yesterday. So that memory is what? Your physical memory only. If you give total memory, by default, by having zero administration memory management utility, it is configuring all your memory areas. So you need not to give role memory size, extended memory size, heap memory size manually. But earlier days, you used to have, you need to give all these memory parameters. So all these physical underscore mem underscore size, em initial underscore size, so entire extended memory size, this parameter you have to give manually all these parameters at that time. But abap underscore heap underscore area underscore total, and for dial process, for non-dial process, all these memory parameters you need to give manually at that time. But now not required by having zam, zero administration of memory management. Is it fine? And I want to show you something, right? What is that? The memory areas. We don't have role memory now, only we are having extended memory and private memory. See, memory allocation on of dialog work process, allocation sequence of dialog work process. First extended memory, then private memory. Where is role memory? Gone. Now dialog, extended memory and private memory, only two things are there. Then for allocation of non-dialog work process, first private memory, that is your heap memory, then extended memory, no role area. So this memory management concept has changed, but so many people don't know this. That is the reason they are arguing with you guys at the time of interviews. See, ZTTA underscore role underscore extension underscore dia means in shared memory, how much memory a dialog process can utilize. So ZTTA underscore role slash underscore role underscore extension underscore non-dia means when a non-dialog process comes into extended memory, how much memory it has to utilize. That is what that parameter. Okay, initial underscore size underscore mem is, that is total extended memory value. Is that okay? Is it fine? Any doubts here? So go through this, you'll understand. If you have any doubts, please come to me. So now I'll show you all the old parameters now, then I'll go with the new parameters. So previously you used to have all these parameters. Sorry, wait for 1 minute. This is old version actually. I'm showing you old parameters also. How your role memory, role first is configured there. So previously we used to have only one instance, that we used to call it as central instance. There only we will be having message server, dispatcher, all other work processes, NQ, dialog, background, everything. There is no concept of ASCS and PAS at that time. No message server and NQ separated. Everything is central instance only. But now your central instance is distributed into ASCS and PAS. The olden days central instance only. Okay, now it will give me login. After that I'll show you the new configuration also, no worries. For showing you this, I started this one. My screen is visible?
Yes, sir, it is visible.
ST02 for memory parameters. See, what you need to monitor here means the buffers, main thing buffers. Your hit ratio, you have to look at this hit ratio. Your hit ratio should be more than 90%, then only your system performance is good. Remember this. Hit ratio of all these buffers, there are so many: program buffer, single record buffer, export import buffer, okay, table definition, all these buffers, all the buffers hit ratio should be 90% or more. That is first rule. And only exception for program buffer, single record buffer, and export import buffer. These three: program buffer, single record buffer, export import, these three can be less than 90%. See, if it is 48%, okay. Single record buffer 58, okay. And this program buffer 73, okay. But all other buffers should be more, hit ratio should be more than 90%. Okay, if hit ratio is less, there should be no swaps. Okay, my hit ratio is less than 90%, and I should not have swaps at the same time. If I am having swaps here and I am having hit ratio less than 90% means you are in trouble. Remember this. So all for all buffers, hit ratio should be more than 90%. Only for program buffer, single record buffer, export import buffer, you can have less than 90%. And you should not have swaps here. Only restriction exception for your program buffer. Program buffer you can have 10,000 swaps per a day. That is maximum limit. 10,000 swaps per a day for program buffer. For other buffers, no buffers should be there. That is the rule. And when it comes to here, see role area, extended memory, heap memory. What is this paging area, guys? Paging area. So you have given some virtual memory. Did you remember that? That is what this paging area, role area, and extended memory. When you compare this role area, current utilization, this is current utilization KBs, should not be more than in memory. So in memory you are having some 75 KB. If your utilization is more, almost to 75 KB means what? Almost your role area is eating up, right? So in memory should be more when compared to current utilization. And extended memory also. So how much it is utilizing? See 46 KB. And how much you are having in memory? 627 KB, right? So in memory you are having 627 KB and you currently in using is 46. Okay, fine. But if this is 550, 560, up to 70 to 80 percentage of your extended memory means you have to think about tuning the memory parameters. Remember. And heap memory also, it should not be utilized. Remember, if you, and your entire heap memory is nothing is utilized now, heap memory. If heap memory is utilizing means you are in trouble. So this is how you have to look at your memory parameters. If you want to tune this memory parameters, which parameters is having which configuration, you can check current parameters. See, I'll show you what is the memory parameter. See, all these are buffer related parameters. All these are buffer related parameters. Your memory parameters are here. If you go here, see this one, ZTT underscore roll underscore first. How much memory by default? 1 byte. First amount of role area used in a dialog work process. Each and every dialog work process has 1 byte of role first. So your user context is absolutely more than 1 byte. Yes or no? So what it will do roll out. So it will copy the user context to extended memory. So most of the times at the time of memory tunings we used to do this 1 byte to 1024 bytes. What is 1024 bytes? That is not also big memory, only 1 KB. So SAP is recommending to change this 1 to 124 bytes when you are having some memory issues. So how much you are increasing? 1 KB only. So it is not fulfilling up your things. You have to do rollout on at anyhow the system itself, it will do the rollout. But sometimes SAP is recommending to change that value to 1024 bytes. It is 1024 bytes means what? 1 KB only. Okay, and this is role area size. What is this? Role area 16. What is this? KBs, bytes. It is also bytes. And this is your extended memory total size. Okay, this is abap underscore heap underscore area 2 GB, non-dia 2 GB, total 2 GB. This is how you have to configure. Okay, these are all your memory. Roll first. The important parameters are roll first, and this is your page memory size. So you have given some part of paging file. This page memory is added to your shared memory sometimes. So your extended memory, where your virtual memory, you are configuring some virtual memory at the time of installation, where it is going. The shared memory will use that hard disk memory. That is what your this parameter. And this is your extended memory size. This is your heap memory size. This is your roll first. So you have to change these parameters. How you change these parameters? From here also you can change. So if I want to change this roll first, Let's go to profile parameter, display, and say change value. You can do that. It is dynamic parameter. How you are saying it is a dynamic parameter? See, it is dynamically switchable. It is a dynamic parameter. So you can, it is
Change it.
taking you to which screen? What is this screen? Anyone? What is this screen it is taking you to? RZ?
RZ11. Change
RZ11. See,
values.
transaction RZ11. It is taking you to RZ11 screen. So you can directly go to RZ10 and check the parameter. If it is a dynamic parameter, go to directly RZ11. If it is a dynamic parameter, check change from here. So if it is a dynamic parameter, you will be getting this thing here. Dynamically switchable, yes, Nike symbol, and change value button will be there. So you can directly change from there, or else you can come to RZ11 and you can change these parameters. Few parameters are static parameters, few parameters are dynamic parameters. If it is a static parameter, you have to restart the system. If it is a dynamic parameter, you need not to restart the system. You check what all the parameters are static, what all the parameters are dynamic. So these are the things you need to check in ST02. For memory tuning, what is the T code? ST02. Give me 1 minute, I'll start that new system now. So you have seen all these parameters, old parameters. In the new parameters, you won't find that role memory parameters. Gone. This is server 2003, guys. See, I'm logging into NetFever 7.4. So hit ST02. So many things are changed here. See, all the buffers, program buffer is there, export import buffer is there. There is no single record buffer. Instead of that, initial record buffers is there. So your hit ratio should be 90% or more for except your program buffer and export import buffer. And you should have no swaps. Only swaps allowed for your this initial records. And when it comes to your memory areas, the gone, role memory gone. Only heap memory is there, extended memory and heap memory is there. This page area is your paging file. Okay. So no more extended role memory. And when it comes to parameters also, there is no parameter related. All these are buffer related parameters, and the new parameters are there is no role underscore area underscore that parameter. What is that parameter? Role first, ZTT underscore role underscore first. No role area parameter. No, everything is your extended memory. EM means total extended memory. This is your total heap memory, and dial over process heap memory, non-dial over process heap memory, and this is your page memory related parameters. Only few parameters are there. So your role memory is obsolete now. If somebody asks you, you can tell this. If you want to change parameters, yes, it will take you to that RZ11 or the RZ10. This is what your memory management. Okay, what all the memory areas you know? Role memory. So when you start your SAP system, what happens? It will occupy these memory areas from your RAM, and it will start and your processor start some processes. Each and every process require some memory. So from where you are getting memory? From here you are getting your memory. From extended memory and heap memory, you are getting memory to work processes. So dial work process will utilize different kind of memory usage sequence, and non-dial work process means all other work process will use different kind of memory utilization. Chalo, that's it from my end. Any doubts?